Hello, this is June. We're going to solve a problem today. It's called a Josephus problem. And this is a problem where um, uh, we eliminate every third remaining person in a circle until no one was left. And we're going to identify the person who's surviving, who will be surviving. But in this case, in our case, we're gonna solve our variation. We start with n people numbered 1 to n around the circle, and we eliminate every second remaining person until only one survives. So for example, here's the starting configuration for n equal 10. And as you can see here, the remaining person until the remaining person, after we eliminate every second remaining person, that it will be, let's see, so starting from 1, the second person is 2, so we remove that person. And next is gonna be second to 3 is 4, 6, 8, 10. And then second to 1 is 3, second to 5 is 7, second to 9 is 5, and second to 9 is 1. So we're removing so the remaining person is 9. Oh, wait a second, I may be wrong here. Just give me one sec. Remove until 1 remains. So second person, remove, then 3, 7, 1, 9. Okay, so the survivor is 5. So if we express this as function, where n is equal to number of people, in case of J10, it's going to be 5, right? So we can organize this in a manner where we have a number of even people and odd people. In case of even number of people, we have we'll have all the even number got rid of. Actually, odd number got rid of. No, even number got rid of until we have another round of from 1 all the way down to 2n minus 1 people. That is equivalent to having n people, just that the number label that people have is going to be 2 times minus 1. So what I mean is that, let's say we have J12. It's going to be, after one round, there's going to be 1, 3, 5, 7, 9, 10 people remaining. I'm talking about this case. And this is exactly the same as J6, except that the position of each people at each spot is 2 times of that person. If it were on J of 6, so in case of 1, second spot second spot from j2 to n is 3, jn is 2. This is just 2 times 2 minus 1. And for 3, its position at j2n is 5, which is 2 times 3 minus 1, all the way down to 11. So j2n, we can generalize and make an equation here, is that j2n is equal to 2jn minus 1, right? There, this position and this position, we're gonna have the same position as a survivor. We don't know which. In case of 6, it's gonna be 5, and in case of j2n, it's gonna be 9. It's gonna be in the same position because the rules are same. Every second person is gonna be removed until one remains, and it's just the number that position is labeled is different, but there's a rule from jn to j2n is it's 2 times the position minus 1. So we can generalize the approach for even number is that j at 2n is equal to 2jn minus 1. And for odd number people, it's going to be 2jn plus 1. So the following recursion is that j at 1 is 1, j2n is equal to 2jn minus 1, 2j2n plus 1, which is an odd number, is that 2jn plus 1. So this is the key for understanding recursion for solving Josephus variation problem.